Welcome. So this video is about homework 2, which you'll find on Canvas and also on the course website. A couple of notes before we get started. I'm going to give you a little bit of an overview of the homework and show you some of how it works. So a couple notes though, I'll be returning the graded lab 2 sometime during the week of the 6th, so look out for that. Also, keep in mind, you may have seen the announcement, but that you can change your course registration to pass-fail if you would like, and that deadline has been extended. Now, I'm not recommending that any of you change it for this class, but it's good to keep in mind for other classes. So talk with your advisor if you have questions about that. So this homework 2, has 2 main programming parts, plus a couple of other questions covering sensing and PID. The first question that relates to programming is focused on developing ROS nodes and computing statistics based on data that you can get from a node that I'm supplying. The second is on implementing a Kalman filter. So let's talk a little bit more about these problems. So you can find on the course website and also in Canvas a link to the homework and also code that you can download that's required for this homework. In terms of the homework itself, you can find it here. And basically, as always, remember to keep track of how much time you've spent on the assignment, as I want to know that in your homework. And for the first question, we're creating this package called Homework 2 Stats, and I'm giving you 2 pieces of code that need to go in there. The first is called rawstats.py, and the other is offensive play.message. So there are a couple of questions related to this in terms of, how do you create the node? How do you actually make sure that it can compile and use the message? And then you also have to now write code to actually parse that message and plot some of the information there. So if we look now in ROS here, I've created the package itself, so I can start the ROS core, and once I have the core running, I can do a ROS run on homework 2 stats and the raw stats. And then I can do ROS topic list and see that there's a message being published on the topic plays. So with plays, I can do an echo. And now this is showing data that we're going to use to actually compute statistics. So basically this is a node that's like we're playing a football game, and this is the statistics saying if you have a pass, if the pass is completed, and how many yards it was for. So you're going to need to basically look at these statistics and figure out, write a new node to actually compute some statistics based on this. Okay, so this is the first part of the programming part of the homework. The second part of the programming part is actually to create a Kalman filter. So in this, I've given you another node that you need to create the full setup for. So I've done that under homework 2 rocket and running this rocket ship node. And now if I do ROS topic list, you can see that there are actually a number of topics being published. So there are sensors. So the idea here is that this rocket ship can sense the acceleration and velocity, and it can control the acceleration. Now I've also provided you with ground truth information on the acceleration, altitude, and velocity. This is very useful because you can actually use these to test your Kalman filter. So if your Kalman filter does not work with these with no noise added in, then you know something is wrong. So what you need to do is first write the equations that define the process and measurement, in matrix notation. So look at your class notes for a reminder on how to do this. Write the Kalman equations for this, and actually implement the Kalman filter that uses just the sensed acceleration and velocity and a control input on the acceleration to then produce a proper filter. So one of the things that I have as some hints here. So you can use, instead of the sensed values, you can use the ground truth values for velocity and acceleration to start out with. Or if you actually look at the code, which I always I always recommend you do, is if we go to the rocket scripts and look at rocketship.py, what we can see is that what we have here is actually that the sensed acceleration has some noise added to it, which is a Gaussian, and the sensed velocity also has some Gaussian noise added to it. So what this means is that if you comment out temporarily this Gaussian noise, you can also use those topics and see how well your filter can perform when there's no noise. Finally, one of the questions you have to figure out and solve is, how do you actually tune the R and Q matrices, the noise measurements here? Now, these are matrices, but one of the things you can try to start out with is assume that each element in the matrix is independent. What this means is that there are only entries on the diagonals of that matrix. So I'd recommend that you start out by trying to use Q and Rs that only have diagonal elements, and you can use as a starting point some of these you have the Gaussian inputs to these that tell you what the actual noise is there. So that can help you hopefully make some progress on initial R and Q values, but then largely you're going to have to try different tuning values and explain in this question why you picked the values you did and how you got to them. So if you have any questions on these, please make sure to post in Canvas and ask myself and other people in the class. Finally, remember, for submission, you need to submit this on hand-in. I want a PDF of the assignment and all the code in one zip file, in a way that if we unzip it and put it in our own Catkin source directory, it'll compile and run as is.